Yes, scholars, you're welcome to the class. Yes, you're welcome. Inform your friends to join. So, as I had informed you last time, today we are going to look at the second subtopic of mole concept, and this one is going to be about empirical formula. So, let me hope you people you had an highlight, or you went and saw the class that we had last time. It was about calculation of molar mass and calculation of mass of a substance from an equation. So before we start our lesson, I know there are some new people that will be in the class, and they're asking, who is this one? Where is he coming from? So the person speaking in the background is coming from an academy known as Pass Chemistry and Biology Academy. So the Pass Chemistry and Biology Academy, it looks at helping candidates, specifically senior 4 per now, to enroll good scores or good grades in their final exams. That is the major highlight of the Pass Chemistry and Biology Academy. However, of recent, they have also joined or added another subject, that is physics. However, specific topics in physics are also added to the academy, and they are going to be taught. So on top of the senior 4 candidates, it also caters for O-level. Per now, it caters for A-level, but it is going to be soon adjusted to A-level. So who is the person speaking at the background? So my name is Mr. Henry. It is noted here in red, and I do teach those subjects that you're seeing there. This class is happening now, but it is happening in the premium group. So there are some people that are not in the premium group. They're like, where will I find Pass Chemistry? I've just joined today, I don't know where to find Pass Chemistry. So if you're new, the number that you see here is my WhatsApp number that you'll use to inbox me and see how do you join the Pass Chemistry, such that you also enroll to having better standards by the terms of your academics. Yes, so that is all about the academy. Maybe to join the premium group, it costs a fee. Yes, and you'll be informed about that fee. Let's first start our lesson. So we are saying today we are going to handle a topic, and it is known as mole concept, but under subtopic that we are calling the empirical formula. First and foremost, always when we open a new topic, it's always good for us to have an highlight, or to have a highlight of what it means. Okay, so what is empirical formula? That's what is going to be answered first. So when you speak of empirical formula, I know there are people that have heard it for the first time. This is a formula of a compound. This is a formula of a compound which shows the number of atoms, and the simplest ratio in which they exist, the simplest ratio in which they exist. So that is the definition. So eyes open as I start explaining it. Yes, so we are saying empirical formula is a formula of a compound which shows the number of atoms and the simplest ratio in which they exist. So everyone knows that we have things that we call compounds. Okay, for example, we have a compound of let me say salt, which is sodium chloride, and it looks like that. Now, what is the empirical formula all about? Empirical formula, it shows us the number of atoms that are in this compound. The compound is what? Sodium chloride. So it is going to show us the number of atoms of the sodium that we have here. Okay, it is going to show us the number of atoms of the sodium that we have here. How many are they? Do we have one atom of sodium? Do we have two atoms of sodium? How many? It will also show us how many numbers of the chlorine atoms do we have here. Are they 2? Are they 3? However, when it is showing us the number of atoms in a compound, it shows us this number of atoms in a simplest way, in a simplest ratio they exist. It does not give us the exact number of atoms in the compound, but rather it gives us a structure, a simplest ratio in which they exist. What shows us the exact number of atoms? What shows us the exact number of atoms that exist in a compound? That is what we call the molecular formula. So when we reach on the molecular formula, I'll be explaining that to you. Okay, when we reach on the molecular formula, I'll be explaining. But it is the molecular formula that now shows the exact number of atoms in the compound. This one just gives us a simplest ratio. Let's go and see how we calculate. So we have a sample question here. They are saying a mass 1.5 grams of magnesium completely burned to form 2.5 grams of magnesium oxide. Remember, when you are reading our scenarios, it's always good to be analytical. You read as you're interpreting. So they are telling us a mass 1.5 grams of magnesium completely burned to form 2.5 grams of magnesium oxide. Everyone knows that anywhere we have heating or anywhere that we have burning, there is involvement of what? What supports burning? Very good, in the comment section. It is oxygen gas. So it means that anywhere we see burning or heating, there is involvement of oxygen. Now they are telling us a mass of 1.5 grams of magnesium completely burned to form 2.5 grams of magnesium oxide. Calculate the empirical formula. How are we going to calculate it? Now, first and foremost, when you're going to calculate the empirical formula, you should know the elements present in that compound. That is step 1. Let me write it here. Step 1, we should do what? We should know the elements. We should know the elements. We should know the elements that make up the compound. That make up the compound. That is the first thing you should know. The elements that make up the compound. Elements that make up the compound. So if you read this question here, they told us a mass 1.5 grams completely burned of magnesium completely burned to form 2.5 grams of magnesium oxide. This means that we have already known our elements present. We have said where we have burning there is oxygen, and they have also spoken of magnesium. This implies that we are having two elements, magnesium and oxygen. However, we have a formula that we follow for us to remember when we are calculating the empirical formula. This is the formula. The formula goes E it is E C M squared, M squared, or what I can say MM, ECMM, ECMM, where E stands for elements present, elements present, C stands for composition, C stands for composition, of which this composition can vary. It can either be in percentages, it can either be in percentages, or it can be in mass. Those are grams, okay? Then from ECMM or ECM squared, elements present, composition, then we have what we call, there's what we call, after that we have what we call moles present, moles present, moles present. We are going to handle this very well step by step. From moles present, lastly, the last M stands for mole ratio, mole ratio. So this is the formula that we are going to be using anywhere you see empirical formula. This is what we are going to be using, and we draw tables when we are calculating this. Hope you know that, or hope your teacher has told you, for those that have learned empirical formula. But how are you going to remember these things of elements present, composition, moles present? We are going to take our synonym, or just this kind of thing to remember it, ECMM, ECM squared, where M stands for, where E stands for elements present, C stands for composition, and this composition can either be in percentages or mass. The first M stands for moles present, the second one stands for mole ratio. Let's start the question. So we have already identified, for those that have been analytical, we have already identified the elements present, the ones spoken about, and there are two. We have magnesium. Now, since it is a formula, you should use the symbol of magnesium. Don't write the word. Once you write the word, you'll be crossed. It is a formula. Formulas are written in short forms. So write the symbol of magnesium. So we have magnesium. From magnesium, we have seen that we have also another element, which is oxygen, and oxygen is symbolized by capital O. Hope we are together, scholars. From there, we are going to go to the composition. In the question, they told us a mass 1.5 grams of magnesium. Let me even highlight it. It is here. A mass 1.5 grams of magnesium, meaning they gave us a mass of magnesium, but now this time around they gave it to us in mass, not percentages. So you come here in the direction of composition and write its mass, 1.5. In the line of magnesium, as you see here, it is in the line of magnesium, 1.5 grams. Okay, 1.5 grams. Then you go to oxygen. Let's read the question and we see. Did they give us oxygen? Completely burned to form 2.5 grams of magnesium oxide. Magnesium oxide, it is a combination of magnesium and oxygen. It is a combination of magnesium and oxygen. Meaning, for us to get the remaining of oxygen, we are going to say 2.5 minus 1.5. All people have understood that. We are going to say 2.5 grams of the whole oxide minus 1.5 grams, minus 1.5 grams of the magnesium. So the balance it gives us, it is the balance of oxygen. Okay, equals, so this will give us 2.5 grams minus 1.5 grams. It gives us 1 gram. This 1 gram it has given us, it is the mass of oxygen. mass of oxygen. This is the mass of oxygen. So scholars, I'm going slowly. I think you're seeing the steps that we follow. Since here they gave us magnesium oxide, it is a combination of magnesium and oxygen. So you subtract. So we have known here the percentage of oxygen. Oxygen is 1 gram. 1. You come here in the line of oxygen and say 1 gram. That is all with the composition. Then under moles present, what do we do? Under moles present, we divide our element numbers or our masses that are given by the mass number in the question. Now, the mass numbers or the atomic masses, they will always be provided in the question. Like this question here, they said, calculate the empirical formula of magnesium oxide, and they told us Mg is 24. 24 is the mass number of magnesium, or it is the atomic mass of magnesium, where O, which is oxygen, is 16. 16, it is the mass number of oxygen. These numbers will always be provided in your paper, so don't worry. So you will simply do this. You will come here below. So for now here we are going to come below. Below magnesium, we want to know, we are on the line of moles present. What do we do under moles present? You get the mass of magnesium, which is 1.5. 1.5. Then you simply divide it. I don't know which symbol I can use for you to understand. Okay, let me do like this. Once you reach there, you divide. So you divide by the mass number given to you in brackets. They told us magnesium here is what? Is 24. So you come here and say 1.5 divided by 24. That is its mass number. Then you go to the side of oxygen. Oxygen, it is 1 gram. But the 1 gram, you divide it by the mass number, which is 16. Hope everyone is following. Then immediately you finish that, still in the space of moles present, you come down and write the answers in the space of moles present. Okay, so 1.5 divided by 24 is what? It's always good to record to 4 dps. It is 0.0625. 0.0625. Very good. Then let's go also and divide on the side of oxygen. 1 divided by 16, it is 0.062. 0.0625. Yes, you note that this is still in the line of moles present here. They are still in the same line. Are you seeing? From there, we are going to go to mole ratio. What do we do on mole ratio? Under mole ratio, this is what we do. You are going to look for the smallest number from your moles present. It is the number that will divide on both sides. You look for the smallest number. It is the one that will divide on both sides. Now, if we look on these numbers, they are the same. 0.0625, 0.0625. So you divide by any of the two, since they are the same. But if we had a number, for example, let me say, if you had a number like 0.1 and another one was 2.5, here the situation is different. You divide by the smallest. So here we're going to divide by 0.1. Likewise, also on this side, we're going to divide by 0.1. But now, since here the numbers are the same, you divide by any that you like. They are the same. Hope that is understood. Okay. So here when we are going to come here on the space of mole ratio, we say 0.0625 divide by 0.0625. We do the same in the space of oxygen. Let me put this down not to confuse. Okay, we do it the same in the space of oxygen. Also on oxygen we say 0.0625 divided by you come down divide by 0.0625. okay, then you write the answers. You first start with the line of magnesium. 0.0625 divide here, it will give you a 1. Likewise also this side it will give you a 1. So you come here and write your 1. So this is the mole ratio. What symbolizes that is a mole ratio? You put this symbol, these two dots in the middle. Are you seeing them? Those two dots, they symbolize that it is a ratio 1 to 1. So you're done. Nothing else. You're done. What you're left with is to write your formula. Where is our magnesium? Where is our magnesium? Magnesium is here. And this magnesium of ours is simply having a 1. So you come down here in the line of magnesium and say Mg, capital M and a G. Then you come here in the line of, since it is a 1, we don't symbolize the 1. We don't put a 1. If there was a 2, we write the 2. But since it is a 1, we don't write it. Then also come in the line of oxygen, it is 1. So you come and write O. After that, you're going to come down here and say, therefore, the empirical formula of magnesium oxide is Mg O. So that is your formula. Those are your scores. So once you do that for your teacher, everything will be correct. This number always have like 5 scores. This is correct. That's where we start from getting, and they will mark it has 5 scores. Okay, so that is it. Let's try out another one. You first take a screenshot of that. We said the method that we use to remember, we say is cm squared, where E stands for elements present. You can see it. C stands for composition. However, this composition can be in percentages or masses. Moles present is symbolized by M, and the second M stands for mole ratio. Yes. Hope you're done copying that. Let's go to the next question. Then I'll leave you an activity. So what is the other question saying? They are saying a mass 20 grams of a compound, a mass 20 grams of a compound of iron. A mass 20 grams of compound of iron contains 14 grams of iron. Contains 14 grams of iron, and the rest oxygen. Calculate the empirical formula of the compound of iron. Let's analyze that very fast. We said which synonym do we use to remember? The abbreviation we use to remember is ECM squared. Okay, so we start very fast. Where E stands for elements present. C stands for C stands for composition. But now, since here we know the composition, we shall say mass composition. If it is a percentage, you say percentage composition. Here it is still in masses. Okay, so it is mass composition. Then from there, the first M stands for moles present. Moles present. The second M stands for mole ratio. Mole ratio. That is done. So we start answering our question step by step. Step by step, step by step. What is our question telling us? So step 1, we said we first analyze the elements present. So here they said a mass 20 grams of a compound of iron. The compound of iron contains 14 grams of iron and the rest oxygen. Meaning in this compound we have iron and oxygen. But we said write the symbols. We don't write the word iron, but write the symbol of iron. So iron is, each symbol is Fe. But they are true. We have iron and oxygen. Oxygen is symbolized by O. That is done. We go to the next step. Composition. What is the composition of iron? They said a mass of 20 grams of a compound of iron contains 14 grams of iron. So meaning here we have 14 grams of iron. And the rest oxygen. And the rest oxygen. Since they have given us the total mass of the compound, which is 20 grams. Total mass of the compound. Sorry for that. Let me write here. Total mass of a compound, which is 20 grams. And they have also given us the one of magnesium. Sorry, the one of iron. So we can say 20 grams, which is of the whole compound, minus 14 grams, which is of iron. We can get the balance for what? We can get the balance of oxygen, which is 6 grams of oxygen. 6 grams of oxygen. Hope no one is confused. That's why I'm going fast now. So you come here on the line of oxygen and you write simply each grams, they are 6. After that, you're going to come to the moles present. What do we do on the moles present? You divide by the mass numbers given in the brackets. Here they told us iron Fe, it is 56. Oxygen O is 16. So you'll come in the line of iron where you have 14. You divide by its mass number, which is 56. Likewise, in the space of oxygen, you're going to go where you have 6, you divide by its mass number, which is 16. Then still in the same space of moles present, you start calculating. 14 divided by 56. 14 divided by 56, it gives us 0.25. Yes, that is okay. Then 6 divided by 16. 6 divided by 16, it gives us 0.37. 0.375. Okay. Now you're done. That is in the space of moles present. Then we go to mole ratio. What do we do in mole ratio? You divide by the smallest of the two, 0.25 and 0.35. Which is the smallest? 0.25 and 0.375. Which is the smallest? It is 0.25. Meaning on both sides we are going to divide by 0.25. So 0.25 divided by 0.25 divided by 0.25. Likewise, on the other side, we are going to say 0.375 divided by 0.25 It is a rule, we divide by the smallest. Okay, so when we divide this one, it will give us a 1 automatically here, but since it is a mole ratio, this symbol should be there in the middle. Then 0.375 divided by 0.25, it gives us what? It gives us 1.5. 1.5. Now, there are different situations. Whenever you calculate empirical formula and you get a number ending with a 0.5, are you seeing this? 0.5. It is also a rule. You multiply on both sides. On both sides of the elements by 2. Whenever it is ending by a 0.5, we multiply on both sides of the elements by 2. So here we shall multiply by 2. Okay, we say times 2 times 2. Likewise, also this side we say times 2. Why? We multiply only if there's a 0.5. So from there we shall come and get our answer. This is a 2. Don't forget that symbol in the middle there. 1.5 times 2, it gives us a 3. We are done. We are done. So you can come down here and say, on the space of iron, which is Fe, it has a 2. Okay? Then, in the space of oxygen, which is O, it has a 3. You conclude very well. Since it is like that, you come down here and tell these people, the one that are asking you, therefore, the empirical formula of the compound of iron, is, you write it Fe2O3. You're done. 5 scores are waiting for you. 5 scores are waiting for you. How are they going to mark you? Here you have a point, that is 1. You listed this very well. Those are 2, 3, 4, and you can differentiate here. Those are the 5 scores. So scholars, that's how we go about calculation of empirical formula. So please make a closer look. Put attention in what I have written. You can even rewind the video up and down. Maybe not to forget, this class is going to be on YouTube. Once you're on YouTube, don't forget to subscribe. Subscribing is following. Once you follow, you'll always be getting updates about the free classes that I'll be posting. Okay, so that marks the end of the lesson. However, I have an activity for you here. Yes, this is your assignment. Make a screenshot of it very fast. That is your assignment. I'm going to be marking it in the premium group. For those that haven't joined the premium group, it's up to your time to join the premium group. So I remain Mr. Henry, and I come from the Past Chemistry and Biology Academy. Those ones that are not in the premium group, to join the premium group, let me hope you have taken the screenshot of this assignment. So let's go back up. So to join the premium group, you'll have to contact me on this number here, the one I'm circling in blue.